Hello everybody, so in this presentation we will be discussing heat. This is a long presentation. We'll be discussing what exactly heat is, how it moves, and really at the microscopic level also talking about heat. So get ready. Heat is the flow of energy from a warm object to a cooler object. We see this in many different places. We can find it anywhere, and all matter contains heat energy because all matter is composed of particles that are always moving. Thermal energy is the total energy, kinetic and potential of the small particles in an object. It can be transferred from one object to another. Now, thermal energy is the result of the movement of these tiny particles of matter. And particles can be things that are very small, like atoms, molecules, or ions, and matter, which we'll review shortly, is solid, liquids, or gases. As we're talking about thermal energy and we're talking about heat, I want you guys just to pause for a minute and think about what happens when you put ice in a glass of lemonade, especially during the summertime. We know that what's going to happen is that over time that ice is going to start melting in that glass of lemonade. It's going to make the lemonade cooler. So what's happening here is the lemonade is transferring that heat to the ice, making the ice melt. And eventually both the lemonade and the water from the ice are going to be the same temperature. This is called thermal equilibrium, when two different objects reach that same point. I mentioned at the beginning that heat can be found anywhere because all matter is generating heat. Remember that matter is anything around us that has mass, volume, and takes up space. Now, matter can exist in different forms or phases. It exists as solids, liquids, or gases. And again, matter is made up of these tiny particles, molecules, atoms, ions that are constantly in motion, which is causing heat. So again, matter can exist in many different phases. The first phase the phases are solids, liquids, and gases. So as a solid, we're going to see the particles being packed very closely together. And that's what we see here. It has a very distinct shape as a solid. In the next phase, the liquids, the particles are rolling and sliding around more freely. So you can see here that they have more space around each particle, and it's taking the shape of what it is in. As a gas, the particles are moving around freely, rapidly, and randomly, and you can see that here in this picture. They're going all over the place, and they don't really have a distinct shape. And then finally, for them to move from one phase to another, we need to add energy, we need to add heat. So if we start off with a solid, we need to add some heat for it to turn into a liquid, add some more heat, it turns into a gas, and add some more heat, plasma, which we won't be covering in this classroom. If we want them to go from gas to liquid to solid, we have to remove some of that energy for it to change phase again. So again, just as a quick review, as we're adding more energy in the form of heat, the matter changes from a solid to a liquid and a gas. This actually has a specific name. We call this melting or evaporation. So as it goes from solid to liquid, it is melting. And from liquid to gas, we say that it is experiencing evaporation. And finally, how do we know how hot something is? We can measure how hot or cold something is, and that is called temperature. We measure using a thermometer, and then that is actually telling us the average kinetic energy of the particles in that object. Now, I want you guys to remember that when we use our thermometers, we have to use Celsius. But there are other units of measurement for temperature that you can see here. There's Fahrenheit, Kelvin, Rankine, and Reaumur. But again, in this classroom and in most science classrooms, you will be using Celsius to measure temperature. So we've talked about how the heat can move from one object to another, and typically it will move from a hotter object to a colder object so that it reaches thermal equilibrium. There are three different ways that this energy transfer happens. It either happens through convection, conduction, or radiation. Convection transfers heat through the air and liquids. Heat, when it's transferred via convection, spreads in a circular motion, and that's what you see here in this picture, right? So the air is heating up, the particles are spreading out, so it starts to rise because now it's also less dense. So they're not as closely packed together, the particles. That's where they're able to move away from each other and up. And that's why we say that warm air rises. Then, as it begins to cool down, it starts to then fall back down, these cold air particles. And then it just continues its cycle. As it starts to warm up, it rises. As it starts to cool down, it falls again, and on when we see convection happening. Heat can also transfer via conduction. Conduction happens when heat is transferred through one substance to another when they are in direct contact, like your ice in the lemonade. Solids tend to conduct heat better because those particles are a lot closer together, so there isn't quite as much movement between them. And the moving molecules of the warm material are increasing the energy of those colder materials. Again, when you think about conduction, think about the ice in your lemonade. As they slowly start to interact with each other, we're seeing that heat transferring from the lemonade to the ice. Or when you put something into heat, there needs to be direct contact for that heat to transfer. Radiation is the final way that heat can transfer. When we're talking about radiation, this is heat that's transferring in the form of an electromagnetic waves. We can feel it coming off of that hot object. So if you stand next to the heater, you can feel the heat without touching it. Just by standing in front of the heater, we can feel it moving away. All right, so this warms the air using infrared waves, and that radiate outwards until it's absorbed by another object nearby. So again, you think about the heater, that heat is just spreading outwards in the form of waves. So here I want you guys to take just a quick second and think, does fire use all three forms? How does fire use all three ways to transfer heat? So go ahead and pause. I hope you guys paused. Now, the air that's above the fire is heated and starts to rise. As that air cools down, it's going to fall. Then as it warms back up, it's going to rise again. So there we have convection. We can feel the heat from the fire because it's going to come off in the form of waves. So there's our radiation. And then conduction is occurring down here, right? So one piece of wood is transferring heat to the next piece of wood because they're coming in direct contact. If we get our s'mores out and we stick it into the flames, then it's going to come in direct contact with the flames, heat up my s'more, make it nice and melty, and there we go. That's how fire uses all three forms of heat transfer. There are a couple of interesting effects about heat. So, as solids, liquids, and gases are heating, they actually expand. They start to take up more space because they're moving faster and faster. Sometimes with liquids and gases, as they are moving faster and faster, they start to collide and they create a great deal of pressure. So what happens when you have a lot of pressure and it's contained? Sometimes that can cause an explosion. All right. The opposite happens when solid, liquids, and gases are cooled down. They contract, so they take up less space because now the particles are moving a lot slower. Water, however, water is the exception to this. It expands when it cools down. We may have seen this before when we've left the can of soda in the freezer. We come back out and now the freezer is a mess because the can of soda exploded in the freezer. That liquid is expanding and it's taking up too much space. We also see here also what happens when solid liquids and gases are contracting. Here inside the balloon, the gases inside are contracting, so that's why the balloon looks a little different than what we're used to. So I'm sure you're probably thinking to yourself, why is it that warm air rises when we see things like convection, heat transfer by convection? Why does that warm air rise? The reason why it rises is because of density, how compact something is. So if those particles are a lot closer together, they're going to be heavy, they're going to be dense, they're not going to be able to lift up. But as they heat up, they start to move faster and faster. They're not so closely together because now they're taking up more space and moving around a lot more. They are less dense, they are lighter, and that is why they are able to rise.